Hello everyone, my name is Dr. Ritesh Singla. Today we will start a new series in which we will discuss the mathematics and reasoning based question asked in UPSC CSE 2026. I will try to provide a best solution to these problems, the way to tackle it, and a very simple solution. The paper we are discussing is set A, so you can refer to your set for any specific question. So let us start with the first five questions of set A. It says that each of these five questions need to be answered in in these four things. So basically we need to choose option A if the question can be answered by one of the statement but cannot be answered by the other statement. Option B if the question can be answered by either of the statement. Option C if the question can be answered using both the statements but cannot be answered if we are using only one. And option D if you cannot answer the question using both the statements. So let us start with question 1. It says that X receives 3 coins of different denomination. So the denomination is given to be 1 rupees, 2 rupees, 5, 10 and 20. Total amount received by X is M and X receive a coin of denomination 5. So क्या कह रहे हैं कि हमारे पास तीन सिक्के लेने हैं हमें जो 1 रुपए के, 2 रुपए के, 5, 10 या 20 रुपए के हो सकते हैं. ठीक है, हर कोई सिक्का है वो डिफरेंट होना चाहिए. जो टोटल है वो m रुपीस है. तो हमें बताना है कि m है वो प्राइम नंबर नहीं है. तो m प्राइम नंबर नहीं है तो क्या हमारे पास क्या 5 रुपए का सिक्का था या नहीं वो हमें बताना है. अब देखो अगर मैं तीन सिक्के ले लेता हूँ एज 1, 2 और 5 तो टोटल हुआ 8. तो इसका मतलब नोट प्राइम. लेकिन अगर मैं सिक्के ले लेता हूँ 2, 10 और 20 so total is 32 which is also not a prime, right? So if the total is not a prime number we cannot really guarantee whether we have a 5 rupee coin or not. So the statement 1 is incorrect. So from statement 1 we cannot justify anything. Now look at this. The sum of the digits of m is greater than 5. So what do we mean by sum of the digit? For example, if you take this number 32, the sum of the digits is 5. If you take this number, the sum of the digit is 8. Okay. So what they are saying is if the sum of the digits of m is greater than 5. So suppose you are not taking any 5 rupee coin. So either you have 1, 2, 10 or 20. So basically what could you have? 1, 2, 10, 1, 2, 20, 1, 10, 20 or 2, 10, 20. These four denominations are possible. Sum is 13, their sum is 4, sum is 23, sum is 23, their sum is 5, sum is 31, sum is again 4, and here the sum is 32 and sum of the digits is 5. So if you see, if we are not having a 5 rupee coin, no matter which denomination we have, we cannot really exceed the digit sum to be 5. But it is given that the sum of the digits of m is greater than 5. So it means that we have at least or exactly we can say one coin of denomination 5. Denomination 5. Right? So statement 2 is alone enough to guarantee that we have a coin of denomination 5. So what should be the option? Option A. Okay. Let us move to the second question. It is saying that for two distinct real numbers x and y, which of them is bigger? So they are saying that x and y are two numbers. We need to tell whether x is less than y or x is greater than y. Which of them is true? We have given these two statements, right? If you see here, the first statement x square is less than y is less than 1, right? Let me just tell you one small result. It is from real analysis. Between any two real numbers, there exists a real number. Real number, and let 0 is less than x is less than 1 be any real number. So what do I know if x is in between 0 and 1? We know that x square is strictly less than x is strictly less than root x. Now we can find some real number between x square and x, and again some real number between x and root x. Let me write those numbers as x square less than y1 less than x less than y2 less than root x less than 1. Fine. Now if you see, this y1 is satisfying statement 1 because y1 is greater than x square and less than 1. This y1 is again satisfying equation 2 because y1 is less than root x is less than 1, right? But at the same time, this y2, it is also satisfying both the condition because x square is less than y2 is less than 1, y2 is less than root x is less than 1. So you have one y1 which is satisfying statement 1 and statement 2. You have a y2 which is also satisfying statement 1 and statement 2, but y1 is less than x is less than y2. So basically, if you are just given these two statements, you cannot really guarantee whether your number y is less than x or greater than x, right? So that is why even if you have both the statements, you cannot really justify anything. So option D is correct. Is it clear? Like, what are we doing here? We are saying that if we have some number y which is greater than x square and less than root x, so can we guarantee that that number y will be greater than x? No, we cannot guarantee because y1 is there. Can we guarantee that that number will be less than x? Again, no, because you have a number y2 which is also satisfying both the statements. So in that manner, answer to question number 2 will be option D. Okay, let us move to the third question. It is saying if x and y are integers, then x is even. So the query is whether x is even or not. Okay, now look at first statement. X square y square is even. Again, this is a very basic result of real analysis. If m is any real number, then m square is even if and only if m is even. What do we mean? That a number is even if and only if its square is even. You cannot find a even number whose square is odd, or you cannot find a odd number whose square is even. Okay, and if you have product of two numbers which is even, then at least one of them is even. If product of two numbers are even, sorry, is even, then one of them needs to be even. These are very basic results of real analysis. I should not really call them results. These are basic observations. Okay. So since x square y square is even, this implies either x square is even or y square is even. Right? From second statement. And from first statement, either x is even or y is even. So see that we cannot really guarantee here whether x is even or not. X can be odd if y is even. So that is a possibility. So statement 1 alone cannot justify anything. Now coming to statement 2. 1 plus x square plus y square is odd. This implies x square plus y square is even. Now again, sum of two even numbers or sum of two odd numbers are even only. So this implies either x square and y square both are even or both are odd. That is either x and y both are even or both are odd, right? So again, statement 2 alone cannot justify whether x is even or not, right? But if I merge these two statements, what statement 1 is saying, either x और y is even, मतलब दोनों में से कोई एक तो even है. स्टेटमेंट 2 क्या कह रही है कि अगर एक इवन है तो दूसरा भी इवन होगा, राइट? सो इफ आई जस्ट मर्ज स्टेटमेंट 1 and 2, we get both x and y are even, right? Again, note that from statement 1, we got that either x or y is even. From statement 2, we saw that x and y either both even or both odd. So none of them alone were able to justify anything whether x is even or not. But if I merge them both the statement, then I get the information that both numbers have to be even. So the correct option is C. Like when you have both the statements, you are able to justify it. If you have only one statement, you cannot. Let us come to the fourth question. Here, x is a collection of certain odd numbers, whereas y is a collection of certain even numbers. Which odd numbers, which even numbers, we do not know. But all the numbers in x are odd and all the numbers in set y are even. T consists of the numbers, all of which are either from x or from y. So T is subset of x or T is subset of y, right? What it is saying, either all the numbers in T are either odd or even and they are taken from x and y respectively. Is every number of T from y? क्या क्वेश्चन पूछ रहे हैं कि क्या जो टी के अंदर जितने भी नंबर है क्या वो वाई से हैं. बेसिकली क्या टी के अंदर जो भी नंबर है क्या वो सभी के सभी इवन है. अगर क्योंकि वो आप प्रूव कर पाते हैं, इफ वी आर एबल टू प्रूव that all the numbers in T are even, then we are sure that all the numbers of T come from Y, right? Now look at first statement. The sum of any two numbers belonging to T is even. So if we are saying X and Y belongs to T, implies X plus Y is even. But you know that sum of any two odd numbers is also even. So from this statement, we cannot guarantee anything. Let us see statement 2. If both P and Q are picked from T, then P minus 1 into Q is even. So P comma Q belongs to T and P minus 1 into Q is even. Again, if P and Q are both odd, then P minus 1 is even, product is even. If P, Q are odd, implies P minus 1 is even. This implies P minus 1 into Q is odd. And if P and Q are both even, this implies P minus 1 into Q is even. So again, you cannot really justify whether all the numbers are even or odd. So even if we have both the statements, we cannot justify anything. We cannot guarantee that all the numbers are even. So option D is correct. Coming to the next question, it is saying that if x, y, and z are integers, each greater than 1, then x is a prime number. Okay. So, but we are given that we have three integers and all of them are strictly greater than 1. Okay. And we need to check whether x is a prime number or not. Let us see statement 1. It is saying xy square is equal to 116. Let me try to write it in a format of xy square. You will see that it is 2 into 58, which can be written as 29 into 2 square. Basically, I'm just writing it in a prime factorization form. So if you see, that is the basic prime factorization of 116. There is no other way possible. Comparing both sides, x is 29, y is 2. Hence, statement 1 is correct. Statement 1 is sufficient. Right? From statement 1, we can able to do it. Let us see statement 2. X into z is 261. If you again see it you will see that it is 29 into 9, which can be written as 29 into 3 into 3. This implies either x is say 87 and z is 3. This implies xz is 261. So statement 2 cannot really guarantee that x is prime because x is equal to 29 and z is equal to 9 is also a solution. So basically x can be prime or x might not be prime. You cannot guarantee anything here. So only statement 1 is giving you the result. So what should be the option? That one of the statement is able to provide the justification and the second statement is not. Hence option A is correct. Right? Because from statement 1 we are able to guarantee that x has to be 29, x has to be prime. But from statement 2, x can be 29 or x can be 87. So you cannot really guarantee whether x is prime or not. And you do not really need statement 2 to justify your thing. Statement 1 is alone just justifying it that x is prime. Hence, for question 5, option A will be correct. Let us see question number 8. This is very basic question. From the first instance, it seems that oh, we have so many equations, but it is not at all difficult. If you see here, if you just see first and second equation, a plus b plus c plus d is 17, a plus c is 6. So if you substitute a plus c in the above equation, we will get one equation as b plus d is equal to 17 minus 6, which is 11. A plus c we have as 6. Also, if I just add last two, third and fourth equation, I will get 2 times p plus q plus s plus r plus b plus d is equal to 32. But b plus d is 11 and s is equal to q and p is equal to r. If I substitute them, 2p plus q, instead of s I can write q, instead of r I can write p, and instead of b plus d I can write 11 is equal to 32. This implies 3 times p plus q is equal to 21. This implies p plus q is equal to 7. You have all the information now. See, b and t together weigh less than the total weight of p and q. So if you see b plus t is 11, p plus q is 7. But so b plus t is greater than p plus q. Option 1 is incorrect. P and Q together weigh more than A and C. So P plus Q is 7, A plus C is 6. So P plus Q is greater than A plus C. So this statement is correct. Also, if you see C and D, in order to be sure, P weighs more than Q. You cannot say anything whether P is large or Q is large because you only have P plus Q is equal to 7. Similarly, Q weighs more than P. You cannot say anything. Hence, option B is correct. Let us see the next question. How many words can one form by shuffling the letters of the word Q if Q is always followed by U? So what it is saying, Q is always followed by U. So if I have Q here, I should be have U just after it. So let me put 5 boxes. Okay, so for Q you have only four choices: first, second, third, fourth. Q cannot be in the fifth. That is for sure, because you have to have one box after Q. Okay, so for Q we have four choices. We have four choices, and the next box will be filled by next box will be filled by U. Now what is left? Now we have three boxes need to be filled with letters. Which letters? E, U, and E. So basically 3C2 choices, which is equal to 3. But these three choices will exist for each placement of Q. So hence total choices is equal to 4 into 3, which is equal to 12. Option D is correct. What we have done is we just saw the question. It is saying that you should always follow Q. So whenever you have Q, the next box should be U. They are fixed now. So we see that out of these five boxes, we have four choices for Q. And once we have fixed a Q, the U will be fixed. One of the U will be fixed. So two boxes are filled at that particular time. So we are left with three empty boxes. Suppose I put Q here and U here. So I have left with three more boxes in which I have to place E, U, and E. How can I place it? I can place it as EEU, EUE, and UEE. These are the only three choices. Very basic terminology of combination, that you have three letters on in which two of them are repeaters. So in how many ways we can put them? So it is 3C2. So 3C2 is 3. It these three choices will be there anyways whenever you choose a position for Q. We have four such position for Q. So the total choices will be 4 times 3, which is 12. Right? Let us see the. Okay, let us discuss the last question of this video. So here we are given that there are three people, X, Y, Z. They jump forward by 4 feet, 6 feet, and 5 feet respectively. At 8 a.m., they all were at 199 feet, and we need to find on how many times they will all land on the same mark. So basically, first of all, they will land on the same marks when they will have same amount of feet measured, right? So basically, we need to start with taking a LCM of 4, 6, and 5, which is nothing but 60. So after every 60 units, they will be on the same mark. So basically, if we have started from 199, the next one will be at 259, followed by 319, 379, then 439, followed by 499, right, and so on. What they are saying is you need to tell us how many times they are on the same mark when in between 195 and 1000. First of all, secondly, they were at the same mark at 199. Okay, so you can of course do it by using greatest integer function and doing all the calculation, but the best part and the very small solution will be just to find these instances, and these are very simple because you just need to add 60 each time. So 199, 259, 319, 379, 439, 499. So if you see now you will able to grasp it with more pace because now you have seen the pattern. The next one will be 559, 619, 679, 739, 799, 859, 919, 979. Done. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So there will be 14 such instances where they will agree. So where when they will be on the same position. So option D is the correct answer. So we will stop here for this lecture. We will continue the other questions in the next video. Thank you for watching.